Welcome to Notes 12.35. Today we are talking about pyramids, cones, and frustums. And a frustum is not a made-up thing. It is a real thing, and you will see what it is a little bit later. All right, let's talk pyramids first. So we've got some formulas, again, that you're going to need to memorize. Our first formula is for the lateral area of a pyramid. So the lateral area is all those triangular faces, but not the base. So my lateral area is equal to 1/2 the perimeter of the base times the slant height. So pyramids have two heights. The first height that we're going to talk about is the slant height, and the slant height is the height of a face of a pyramid. So it's exactly what it implies. It's basically the height of each of the triangles that makes up the face. So that right there is my slant height. All right, for my surface area, all I do is I add the area of the base to that. So I take whatever my lateral area is and I add the area of the base, whatever shape my base is. So again, a base can be all different kinds of shapes in a pyramid. It can be anything from triangle up to any kind of n-gon. So it would just be the area of that. All right, and then finally volume. Volume is going to be 1/3 the area of the base times the height of the pyramid. So the height of the pyramid is different from the slant height. The height is the perpendicular distance from the vertex to the base of the pyramid. So it's the straight down. And imagine if this were a, I don't know, fireman's pole, and you would slide all the way down from the top of the pyramid to the floor of the pyramid. That is considered the height of the pyramid. So I will frequently refer to this is the slant height and this is the height. Okay, just be aware that pyramids have two different heights. All right, so let's solve some problems. So we are given that the height of this pyramid is 9 meters. So that is the height. That is the perpendicular distance from the vertex to the base of the pyramid. And then we are told that the edge is 24. All right. So for my lateral area of a pyramid, it is 1/2 the perimeter of the base times the slant height. For my total area of the pyramid, it is that lateral area plus the area of the base, just one base, so just one B. And then for my volume, it is 1/3 the area of the base times the height. So we need to know P, we need to know L, we need to know big B, and we need to know H. All right, so P pretty easy. This is a square pyramid, although we're really not told that, but in any kind of critical situation like a quiz or a test, we would tell you that this was a square pyramid. And so we just take 4 times 24, and we get 96 meters for the perimeter of our base. My slant height, I'm going to need to find. Okay, so in a square pyramid like this, my height is going to hit the center of the pyramid, which means that if this whole side is 24, then this side is 12. And I have a 3, 4, 5 right triangle going on here, right? 3 times 3, 4 times 3, so this would be 5 times 3, so this would be 15. So my slant height would be 15 meters. Area of the base is simply going to be 24 squared. All right, so 576. And then my height is 9. So now I have all the pieces I need to go ahead and solve. So 1/2 96 times 15, which gets 720, and this is what, meters squared. And then I take that 720 and I add to it the area of the base, which is 576. So I get 1296 meters squared, and then I take the area of my base, 576, multiply it by 1/3, and multiply it by my height, which is 9. So I get 1728 meters cubed. Pretty straightforward. Just got to memorize these formulas. All right, I would like you to do this one. Keeping in mind that you can find your slant height. You've got a right triangle, you know 2 of the sides, so you can always use the Pythagorean theorem to find the 3rd side. So go ahead and do that. find all these three answers for me and come back and check your answers. Hit pause now. All right, so you should have gotten 107 centimeters for your slant height, and that means that your lateral area is 19,260 centimeters squared, your surface area is 27,360 centimeters squared, and your volume is 261,900 centimeters cubed. If you have any questions on those, please ask in class. Okay, so here's our first pyramid that does not have a square as a base. We are given that the base edge is 10, and we're given that it's an equilateral triangle, and we are given a slant height of 4. All right, so it asks us for our lateral surface area and our total surface area. So my lateral is 1/2 PL, and my total is 1/2 PL plus B. So let's go ahead and find P, L, and B. P is pretty easy. 3 sides, each side is 10, so 30 meters for my perimeter. They gave us our slant height of 4, and then we have to find the area of the base. So we have a triangle with an equilateral triangle with a base edge of 10, which means that when I drop my altitude here, this is 5, and this would be 5 radical 3. So to find the area of my base, I take my base times my height and divide it by 2. So I take 5 radical 3 times 10 divided by 2, and I get 25 radical 3 meters squared. So now I just plug this all in. So perimeter times slant height, 1/2. Perimeter of 30 times the slant height of 4 gives me 60, and that would be meters squared. And then I take that 60 and I add to it the area of the base, which is 25 radical 3, and I probably should have just written that up here because that's my answer. Again, these are not like terms. They cannot be combined, so that's as good as it gets. Okay, so let's take all this knowledge we have about pyramids and let's translate it to cones. All right, I want you right now to draw for me what you think a cone looks like, and then come back and check and see if you're right. So hit pause now. All right, so I'm sure that those of you who did what I actually asked, as opposed to those of you who just didn't bother hitting pause and just kept on trucking, I'm sure that some of you who did what I asked went and did something like this. You drew a circle and you drew a triangle and you're like, look, it's a cone, just like the ice cream cone I used to draw when I was in kindergarten. Okay, a lot of people think that this is how you would draw a cone, but what you'll find out is if you were actually cut this out of paper and check and see, when you folded these two edges together, this part right here does not form a perfect circle, it forms an ellipse. So the actual net of a cone looks something like one of, oh, it's supposed to move when I click it. All right, looks like one of these two, sorry, right here, where this is my base, and then this curved edge here wraps around that base and comes together to form a point right here, the vertex right there. So just like in a pyramid, there are two heights. Okay, we have the height of a cone, and then we have a slant height. Okay, there's also a slant height and a height in a regular cone. And actually, we could probably see that easier if we had a cone and not its net. So hang tight for a second. Okay, so in my cone here, I have a slant height, which is the height along the edge, and so that will be my slant height. And then just like in the pyramid where I dropped an altitude from the vertex to the center of the base, same thing holds true here with my cone, and that becomes the height. So that is h, the height of the cone. All right, my formulas are actually exactly the same as from a pyramid. The only thing is, just like when we transitioned from prism to cylinder and we had to take into account the difference that the base becoming a circle made, same thing happens here with a cone. So in a pyramid, it was 1/2 PL, okay? But as I transition to cone, that becomes 1/2, perimeter is circumference, so 2 pi r L. Well, the 1/2 and the 2 cancel each other out, and I'm left with just pi r L. So my lateral area is equal to pi r L. And then just like in my pyramid, to find the total surface area, I add my base to that. So I take my pi RL and I add pi r squared to that. So sometimes you will see it with the in its factored form where they factor out a pi and an r. So I factor out a pi and an r and it leaves me with an L plus an r. So these two are the same form. This one is factored. This one is not factored. And then finally my volume is still 1/3 area of the base times the height, or 1/3 pi r squared h. And that is my volume. Okay, so same formulas, just changed to account for the fact that the base is now a circle. All right, so let's do that. So we've got a pyramid here. I'm sorry, we have a cone here, and we need to write down our formulas. So my lateral area is pi RL. My total area is pi RL plus pi r squared, and my volume is 1/3 pi r squared h. Okay, so what we need to know is we need to know what r is, we need to know what L is, and we need to know what H is. Okay, well, we know what L is, it's 13. We know what H is, it's 12. So all we need to do is find R. And this is a right triangle right here. And so if you remember your Pythagorean triples, this is a 5, 12, 13 right triangle. So R is 5. So we just fill in all the pieces. So pi times 5 times 13 gives me 65 pi meters squared. And then I take that 65 pi and I add to it pi times 5 squared. So that gives me 90 pi meters squared. And then I take 1/3 pi 5 squared times 12. And let me see, 1/3 times 12 is 4. 4 times 25 is 100. So 100 pi meters cubed. Sorry, since that's volume. 100 pi meters cubed. Very straightforward. All right, I would like you guys to answer this one for me in the notes check. Very straightforward, exactly like the one we just did, so please go ahead and do that. All right, let's talk about this crazy thing called a frustum. So a frustum is simply a pyramid or cone with the vertex sliced off. It's sliced parallel to the base. So if you look at my example over here, I have a kind of pathetically drawn pyramid, and you'll notice that I can just take and I can slice off the top, and what remains, because this is still a pyramid, right? What remains is a frustum. So it's kind of the difference, between the Egyptian pyramids, which come to a point at the top, and the Mayan pyramids, which are flat on top. So, you can sacrifice people by slicing out their hearts. Not that I'm judging. Okay, and there are two formulas associated with them. Volume, which is missing a parentheses right here. Should be a parentheses after this, which is simply 1/3 the height of the frustum, which is going to be the distance from base to base, right, perpendicular distance from the top base to the bottom base, times the area of base 1 plus the area of base 2 plus the square root of the product of those two areas. And then we have a second one for lateral area, which is the sum of the perimeter of the bases times the slant height divided by 2. Unfortunately, we never ask you to do this one, because that's the easier one. The one we ask you to memorize is obviously going to be the more challenging one because we have such faith in you. So we need to memorize this formula and understand how to use it. H is the perpendicular distance between the bases. B1 is the area of the top base. B2 is the area of the bottom base. All right, let's do this thing. Okay, so the very first thing we should do is we should write down that formula, because that formula is hard. So 1/3 times the height, and then we have base 1 plus base 2 plus the square root of the product of base 1 times base 2, and these are areas. All right, so we need to know what H is, and we need to know what B1 is, and we need to know what B2 is. So let's do this thing. The height is the distance between the bases, even though it looks slanted. That's the only one they've given us, so we're going to have to go with that. So that is 8. And then base 1, if we do our top base, it's a rectangle. It is a 12 by 13 rectangle, so 12 times 13, and that equals 156. And then base 2 is 18 times 19, so that one is 342. All right, so let's fill in all the pieces. So we have 1/3 of 8 times 156 plus 342 plus the square root of, now this should be 156 times 342, but I know that I'm going to want to put this in simplest radical form, so I'm actually going to go back to these factors. So it's 12 times 13 times 18 times 19, right? Because I'm going to need to unfactor this anyway, so it doesn't make any sense to go ahead and multiply these two together. All right, you'll see what I mean in a second. Okay, so we basically have 8/3, and then we're going to add these two together, so that gets me, what, 498 plus the square root of. Okay, let's talk about how we do this. So I want to find the biggest perfect squares that I can find that divide into these things to make my life easier. And 12 is 4 times 3, and 4 is a perfect square. And 13 is a prime number, so that's all I got there. And 18 is 9 times 2, and 9 is a perfect square. And then 19 is a prime number, so that's all I've got there. So what I'm going to do is I'm going to go ahead and I'm going to take the square root of this, and I'm going to take the square root of this, and multiply those two together, and that goes outside my radical. And then everything else, the 3, the 13, the 2, and the 19, because I don't have any pairs of anything else, they all get multiplied back together and stay underneath the radical. So I take my 8/3, I keep my 498. Square root of 4 is 2, the square root of 9 is 3, so 2 times 3 is 6, so I get plus 6. And then I get 3 times 13 times 2 times 19, which is 1482. All right, and then all I need to do is distribute this guy. So when I do that, I get 1328 plus 16 square root of 1482, and that would be, let me see, my units are meters, and this is volume, so it would be meters cubed. Not the easiest thing in the world. Again, these two can't be combined because one has a radical and one doesn't have a radical, but that is my answer in simplest radical form. You'll be relieved to know it's much easier when you're dealing with a cone. So here we've sliced off the top of the cone. Okay, so my formula stays the same. I'm going to write this formula one more time because it's so hard to memorize. So my volume equals 1/3 my height times B1 plus B2 plus the square root of B1 times B2. All right, so we again need to know what B1 is, we need to know what B2 is, and we need to know what the height is. All right, so we need to find the height in this case, because we know what would be considered the slant height, but we don't actually know the height. However, if I make a right triangle by dropping an altitude from the edge right here, and so I've formed a right triangle. If this piece is 3 and this whole thing is 6, then this piece is 3 and this piece is also 3. So I have a right triangle with a leg of 3 and a hypotenuse of 5, which means that the height has to be 4. It is a 3, 4, 5. So I've just found my height. All right. The area of base 1 is going to be pi r squared, so 9 pi. And the area of base 2 is going to be pi r squared, so 36 pi. So when I go ahead and do this, I get 1/3, 4, and then 9 pi plus 36 pi plus, and again, I'm not going to multiply these together. I'm going to take 9 pi and I'm going to multiply it times 36 pi, but I'm not actually going to come up with the number that I get when I multiply those together. And the reason why is, all right, 4/3, and then these two together give me 45 pi, because I can take the square root of 9, which is 3, and I can take the square root of 36, which is 6, so 3 times 6 gives me 18. And then I have pi times pi, which gives me pi squared, and the square root of pi squared, those two undo each other, so it gets me just pi. That's why cylinders are easier than any other shape, or frustums from cylinders are easier, because I'm dealing with r squared, which square roots very nicely. All right, so my final answer is 84 pi, and the units are meters cubed. And that's a much easier final answer than this one up here. This concludes our notes for today. Be sure you memorize these formulas. Go on and do the notes check. And if you have questions, be sure you ask in class. Thanks.